Hi class. So this is the last question that I want to talk about for linear law, okay, which is exercise 8b. Okay, so the reason why I want to talk about it is because if you look at the question, okay, they have given you the equation y equals to hx power k, and they give you a table of values for x and y. Okay, the first part of the question is express the equation in the form that is suitable for drawing a straight line graph. Okay, this is one of the uncommon questions, okay, because commonly we will actually tell you what is big Y, big X. But they didn't tell you what is big Y, neither did they tell you big X. Okay, so we actually have to create our own equation ourselves. Okay, we're using linear law. So from this equation, okay, this is an exponential equation. How do we convert this into the big Y equals to mx plus c? Okay, we can actually do ln both sides. Okay, and after we do ln both sides, we can split up this right hand side. Okay, split up the product. Okay, using product law, okay, I will actually have ln h plus ln xk power k. Okay, but from here I can actually use power law. Okay, I bring down the k. Okay, let me rearrange it. Okay, and the reason why I'm rearranging it is so that I can see who is my big Y and big X. This is my big Y. This is my big X. And finally, my M gradient, my C for y-intercept. And you can see that this is a suitable equation for drawing a straight line graph. Okay, so this is for part 1. Okay, let's look at part 2. Draw the graph using suitable scales and use it to estimate the value of h and of k. So for part 2, you definitely need to draw a table. Okay, draw a table of big Y against big X. And we have already said what is big Y, big X. Okay, big Y is ln Y and big X is ln X. So you need to find your table of values. Okay, these are my table of values at the top. Okay, so you see whether yours tallies with mine. Okay, these are my table of values for ln Y and ln X. So I use that to actually draw my straight line graph. You'll note that not all of the points lie on the same straight line. There is one small tiny outlier here, but this line connects 5 out of 6 of the points. So this is actually my straight line graph. Okay, for part 2, okay, not only you have to draw, you have to estimate the value of h and of k. Okay, so what I will do is, let's look at the context of the question. What is h and what is k? Well, k is obviously my gradient. Okay, gradient is m. And take note that ln h is my c. Okay, so my ln h is actually the y-intercept. Okay, so I think it's easy to find what is k. Okay, k is my gradient, so I can just use any two of the points that matches. Okay, if we look at this point and this point, okay, this will tally with my last two one. Okay, this and this. Okay, so you just use any of the 2 points to help you calculate. Okay, let me calculate what's this value. Okay, I'll get 1.56 to 3SF. Okay, and the answer key actually is close to, okay, is roughly about 1.5. Okay, so this is correct. Okay, so this is for K. Okay, now for my ln H. Okay, ln H for my graph is actually my y-intercept. So you need to extend the line and make sure that it cuts the y-intercept and it cuts at 0.6 from my graph. Okay, so for my graph, ln H is 0.6. Now I just need to find what is H is e power 0.6, and I'll calculate what is e power 0.6. I get 1.82 to 3SF. Okay, so this is my answer. Definitely we will be accepting a range of answers. Okay, probably plus minus 0.5, about there. Okay, so we are accepting of a range of answers. Okay, this is for K and for H. And we're done with part 2. Okay, now the part 3 is to estimate the resistance to motion experienced by the particle when it moves at speed of 18 meters per second. Okay, this 18, okay, it refers to speed, which is x. Okay, and note that resistance to motion is actually my small y. Okay, small y is resistance to motion. Okay, so let's see if my x is 18. Okay, because my speed of 18 meter per second means x is 18. Okay, because speed is 18. Okay, but I can't use this value because I'm not having x as my horizontal axis. Instead, I'm using ln x. So let's calculate what is ln x. Means is ln 18. Okay, when I sub in x as 18, okay, I will get 2.89. Okay, from my graph, where is 2.89? Okay, it's roughly here. Okay, so I need to actually use dotted lines to guide me to this point. The one in red, okay, it helps me to guide in this point. And I will draw a horizontal line until I get, okay, 5.2 as my ln y. Okay, so my vertical axis. So if ln x is 2.89, then from my graph, ln y is 5.2. And if ln y is 5.2, then I can calculate what is y. Okay, it's actually e power 5.2. And what is e power 5.2? 181 to 3SF. Okay, that's roughly the answer key. Answer key is 180. Okay, so again, we'll be accepting a range of values. Okay, plus minus 2. Okay, and in the context of the question, my resistance to motion, okay, is 181 Newton. Okay, so this is my attempt for exercise 8.